Welcome to today's class on chemical bonding, higher secondary first year. And today I have chosen very small part of this topic is bond length, bond energy, and bond angle. And I am going to solve a lot of entrance exam solutions. And for practice, you will do a lot of another examples. Kindly follow the class. And before starting this one, in short, I am telling you. Just I am revising the things that in sp3 the structure is, if there is any lone pair, there is no lone pair here, all are regular structure. sp3 is tetrahedral and it is 10, bond angle is 109 and 28 minutes, and sp3 diagonal bipyramidal 120 degrees centigrade, and sp is the linear 180 degrees centigrade, sp3 square plus 90 degrees centigrade. sp3d, I have given this asterisk because it is very important. Very often in entrance exam the questions ask what are the different types of the bond angles present in sp3d2 sp3d. It is trigonal bipyramidal angle. Two types of angles are present is 120 and 90, and sp3d2 is the octahedral. One type of angle is present is 90 degree, and sp3d3, and here you will guess pentagonal bipyramidal structure is angle is 72 and 90. These two are very important. Very few questions are asked from this topic. Today I am going to discuss about bond length. Give you the small shortcut trick on bond length, and this will be very much helpful in arranging increasing and decreasing order of bond length, and which one is the having least bond length and which has the highest bond length or longest bond length. These are the factors on which the bond length depends. First of all, that is, if the size of the atom increases, bond length will increase. Very simple. If the size of the atom increases, bond length increases, and if the s percentage increases, bond length decreases. Now, how does you tell that bond length increase and decrease? Depending upon this one, let me take one example. NH. If you are asked to arrange an increasing or decreasing order of the bond length, so you will just think about H is fixed. Don't think about H. Here is iodine, bromine, and chlorine and fluorine. And iodine, bromine, chlorine, fluorine are 17 groups, and fluorine, chlorine, bromine, iodine from top to bottom. The size increases. The size of Hi is big, long. So the order is in this way. So the example of the first size increases, bond length increases. This is the reason. This is the example. And then S character. If S character increases, bond length decreases. I will give you a small idea regarding this one. Say it is sp3 and it is sp2 and sp3, single bond, double bond, triple bond. Am I right? Now what is S character? There is one, total parts is 3 and 1 4, and if you divide 100 by 4 you will get 25. So 25 into 1 equal to 25 degree. It is S character. Here there are 3 parts, 2 and 1 3. Divide 100 by 3, you are getting 33.3. So S character is 33.3. Here you are getting S and P. There are 2 parts. So divide 100 by 2, you are getting 50. So S is 50. So in this case, in this way I have seen S character increases. So if the S character increases, bond length will decrease. So the order of bond length, this. More the S character, less is the bond length. The reason is very simple. S orbital is spherical in nature, so more the S character. So in the internuclear, the S will be very close to the nucleus. There will be more and more penetration. So more the S character, more will the penetration in the molecule. If S is more is the penetrations of S orbital, so less will be the bond length. So S connector is more, means bond length is this. Means single bond is the highest, second bond is second, and third triple bond length is the least. More is the S character, less is the bond length. Again, I will talk something regarding the bond energy. The amount of energy required to break the bond of the molecule to make the constituent atom in gaseous form. Say it is methane. So if you take 1 mole of methane and if you try to break all this bond, so you will get hydrogen and 4 hydrogen and 1 carbon. So if all these things are hydrogen in gaseous and carbon in gaseous form, if you break in this way to get the gaseous constituent atom, that amount of energy required to get the constituent atom from the molecule is called bond energy. So now on what factors bond energy depends? Number 1, in short I have taken this example. If the size increases, bond energy decreases. Simple, the fact is very simple. Say HF, HCl, HBr, HI. The size of HI is more. So more the size of H in HF, HF, HCl, so less amount of energy is required to release the to get the constituent atom in gaseous state. So if the size is more, bond energy is less. Very simple. Now multiplicity. Multi means multiplicity. This is single bond and another is double bond and another is triple bond. So that is called multiplicity. Single bond, double bond, triple bond. In terms of S character, 25%, 33%, and it has got 50% S character. 50%. More the S character, shortest is the bond length. Shortest is the bond length, highest is the energy required to break. So if S character increases, means S percentage is increases, so bond length will decrease, so highest amount of energy will be required to break the bond. So if the multiplicity, when you increase the multiplicity, single, double, triple, the S character increases. So multiplicity is increases, means single, double and triple increases, so bond length will go on gradually decreasing and thereby bond energy will increase. Next one, electronegativity. In between these two, let me tell. So if you are asked to arrange in increasing or decreasing order of the bond energy, so what you will tell? Electronegativity increases, bond energy increases. That should be the order should be like this. Fluorine is highly electronegative, then chlorine, then bromine, then iodine. Fluorine, chlorine, bromine, iodine. As you go down, the electronegativity increases as size increases. So what is the point? Point is more the electronegativity, more is the bond energy. So the order should be like this. But there is a twist. Here in this case, please follow, because F bond F, it is a very small, twice p orbital is there and 9 electrons are there. So there is huge repulsion. Due to this fact, it should have the highest bond energy as per the concept or the clue or the points or the trick, but here it will be a bit different. Here FF will come here and Cl and Cl will be, because of FF repulsion, electron repulsion, the bond energy will decrease a bit than Cl and Cl. So this is all about bond energy concept. In class, bond angle. Bond angle. What are the factors? A lot of factors are there. I will explain one by one each. So first of all, you see what I tell in the first one is bond angle. I am talking about bond angle. If S character is more, bond angle is more. Let us take one example. If S character is more, bond angle is more. Means, say one molecule is sp3 hybridized, other is sp2 hybridized, other is sp hybridized. Bond angle, what happened? Percentage of S character increases. I have shown you 25, 33 and 50 percentage of S character increases. Now let's see what's happened if S character increases, bond angle increases. So for sp3 hybridized molecule, say methane, the bond angle of this is, for sp2 it is known to you all, and for sp it is 1A. So from this we infer that if the S character increases, means sp3, sp2 and sp, S character increases, bond angle also increases. Very simple, nothing to explain, you yourself can understand. Now fact number 2, lone pair increases, bond angle decreases. I have already mentioned in previous class, say one is methane, other is water, other is ammonia, and it is known to you so it is quite crystal clear from the fact that methane, ammonia and water, methane is sp3 hybridized, what ammonia is also sp3 hybridized, water is also sp3 hybridized, all are sp3 hybridized. Now what's happened, in case of methane there is no lone pair, in case of ammonia there is one lone pair, in case of water there is two lone pair. So as lone pair increases, bond pair decreases. So you see, when there is no lone pair it is 108, when there is one lone pair 106, and when there is two lone pair 104, means lone pair more, bond angle less. The second point is clear. Now let us tell about something about electronegativity of central atom. If the electronegativity central atom decreases, means directly proportional, bond angle also decreases. Let us take one example, tellurium. Am I right? So it is group 16 and electronegativity decreases in this way. It is known to you all. But what's happened here, if you talk about the bond angle, this is 104, this is 92, and this is 91. This is all about this. So what we infer from this is that oxygen, sulfur, selenium, tellurium, the electronegativity increases. What I tell, if the central atom OS, selenium, tellurium, all are central atom, the electronegativity central atom decreases, so bond angle will also decrease. So bond angle decreases. Electronegativity increases, decreases, oxygen, sulfur, selenium, tellurium, it is decreases from top to bottom, so bond angle also decreases. Now for the board examiner, those who want to appear in the board and want to, for it is a trick for the entrance exam, nothing to explain. For explanation why, if you tell why, so let me take one example only so that you can very easily understand the fact. So in both the cases there are two lone pair, one is oxygen, other is sulfur. What's happened? The electronegativity of oxygen is more than sulfur. Now what is the electronegativity? It is the ability of the atom to attract the shared electron bonded pair, shared electron or bonded pair towards itself. Bond pair of electron is already bonded, shared these two electrons, and due to its electronegativity it will attract this bond pair towards itself. So this bonded pair of electron will be a bit closer to oxygen atom, and in the same way this bond pair will be a bit closer to oxygen atom. So oxygen atom has already two lone pair, there is repulsion, and again there is two lone bond pair which is a bit closer due to the electronegative effect of oxygen. So it is much closer towards oxygen. So there is huge electrons nearby oxygen. So there is a great repulsion, and due to this repulsion the bond angle is equal to 104.5. But in case of this, again it has the ability to attract the bond pair towards itself, but it is not to that extent as oxygen has attracted towards itself. It is a bit weaker. So here what's happened, this bond pair of electron is not as close as oxygen did earlier. So it is a bit far apart from sulfur. So there is less repulsion, electronic repulsion. Lone pair, already two lone pairs are there, and as it has attracted the bond pair towards sulfate to the lesser extent, means it is somewhat a bit far from the sulfur, means repulsion is a bit less. So due to less repulsion of bonded pair, bond angle will be a bit closer, hence it is 92. Same way 91, same way 89.5. So this is the fact. If the central atom of electronegative central atom decreases, bond angle will also decrease, and this is the explanation. Now next point is again important. Here electronegativity decreases, bond angle increases, reverse case, but here central atom is same. Let us take one example. So I have taken two sets of example, but it is very simple. You can explain, and very often these are asked in the entrance exam. Don't be confused. You please follow. What electronegativity decreases, that is inversely proportional. If the less electronegativity, more will be the bond angle. So electronegativity of what? There is no question of central atom. Central atom is same. So we need not consider the electronegativity of central atom. We will consider the electronegativity of the atom attached, Cl, bromine and iodine. So what happens here? Here chlorine, bromine, iodine. Here the fluorine, chlorine, bromine, iodine 17. So electronegativity decreases. So electronegativity decreases, bond angle increases. So electronegativity chlorine, bromine, iodine decreases, bond angle 101, 101.1, 102, bond angle increases. Again arsenic chloride, arsenic bromide, arsenic iodide. It is again the central atom is the same. So chlorine, bromine, iodine, electronegativity decreases, bond angle will increase. So this is the simple trick on as to how we will decide that bond angle varies, bond energy varies, bond length varies. These are very simple trick. Yes, from the previous concept, we will try to solve solution, and within a very short time we will going to solve this one. You just follow this one. First of all, you are asked pH3 bond angle is approximately equal to, there are lots of options. Answer is 90 degree. Mind that I will tell something about pH3. It is a Drago molecule. A bit I have to mention something, that phosphine, the bond angle is around 90 degrees centigrade, and here at this point you should know, which may not know this one, that type of molecule, phosphine type of molecules are called Drago molecules, and Drago molecules are such type of molecules which does not have any hybridization. That molecules does not have any type of hybridization. There doesn't follow any hybridization. There is no hybridization in it. Am I right? Because all the bonds of this molecule, pH3 bonds, are connected to the pure orbital. In such type of Drago molecules, here in this Drago molecules, all the bonds of pH bonds are connected to pure orbital, and bond lengths of all the bond lengths are very short. So this is extra information. Next, you are asked which one of the following is coplanar. Coplanar means in the same plane. The option was BF3, and the correct option is BF3. Lots of other options are there. It is trigonal planar. All the atoms are in the same plane, as they are coplanar. Next one, least bond angle. You are asked NH3BF2 water ammonia. It is appeared in TET exam, and here you see ammonia. It is sp3 hybridized. BF2 it is linear. Water is 104 sp3 hybridized. It is sp3 hybridized. The least bond angle here this is there two lone pair, and here there is one lone pair. So you follow the concept. I told you lone pair is more, bond angle is less. So it is linear 180. There is no comparison with this one. So out of this, it is tetrahedral. It is again no lone pair. So here competition 109 and out of this there is a competition. There is 2 lone pair, there is 1 lone pair. More the lone pair, less is the bond angle. So answer is water. Next one, HCH bond angle in methane is less than CNC in trimethylamine. What is trimethylamine? In trimethylamine you are getting this. This is trimethylamine. Am I right? There is 1 lone pair. So CN bond CNC. So CNC bond angle. So what is CNC bond angle of this and HCH bond angle in methane? So again, methane is sp3 hybridized. I have shown you the way, and this is also sp3 hybridized. This is also sp3 hybridized. But here there is 1 lone pair, but there is no lone pair. So more the lone pair, less is the bond angle, and this bond angle is 108 almost. So HCH bond angle in methane is more than CNC in trimethylamine. The question was asked in BITAA. Just I will explain only concept, nothing else. So greatest bond angle in this. So this is linear, this is tetrahedral, this is tetrahedral. Let us talk about hybridization. This is sp. I have shown you in my past class how to calculate hybridization. This is sp, this is sp3, this is sp3, this is sp3. So the question was asked in IIT, JEE, AMU, Aligarh Muslim University Medical Organization, PMT. Am I right? Very important question. And which has the greatest bond angle? So greatest bond angle. So if it is sp is 180, it is CH4, and all are sp. So now you count the lone pair, 1 lone pair, 2 lone pair. Am I right? So more the lone pair is more, bond angle is less. So you are asked greatest bond angle. So greatest bond angle, you need to compare all this sp, sp3, sp3 around 107, 104 like this. So the sp has the highest bond angle of 180. So answer is carbon dioxide. Next one is CHF3, CHCl3, CHBr3 greater bond angle. Which one is the highest bond angle? So here central is carbon in all the case, carbon is same. When in the bit earlier I have told, if the central atom is of same type, same element, same, so you just talk about the attached atom here, fluorine, chlorine, bromine, iodine. In this case I told you, if the central is same, so electronegativity is less, so bond angle is high. So in this case, fluorine, chlorine, bromine, iodine, from top to bottom in the 17 group, electronegativity decreases, so bond angle will be increased. Less the electronegativity, more is the bond angle. Answer is CHBr3. Next one, again CO2, CH2, water, AgCl2, non-linear molecule. So let us see which one is linear. So you find out hybridization, and it is known to you carbon dioxide is linear. It is sp, and this is also sp, and this is also sp. These all are non-linear. So all are linear. So there is water, it is sp3 hybridized, bond angle should be 109, but due to presence of 2 lone pair, it is distorted band shape. So non-linear, it is asked in PMT. It is not linear is water. So come to the next one, again very important. Very important one is NCl3, SCH3, SbCl3, nitrogen, arsenic, antimony, bismuth. So nitrogen, arsenic, antimony, bismuth, it is in 15 group. Am I right? So electronegativity decreases. So central atom, very beginning I told you, electronegativity of central, if it is less, so bond angle also, it is directly proportional, bond angle also decreases. So you are arranged increasing bonded order, bond angle decreases, means the order will be this. Electronegativity bond increases, the central atom is decreases, so bond angle also decreases. So it is highest bond, it is the least and it is the highest. the order is this. So tremendously important facts are there, and all the facts can be solved out from using the trick. The next and last part of today's class is the correct bond order. You are arranged in correct bond order. So this is CH4 NH3 C2H2. You see, you find out the hybridization, you will get hybridization of these three are, it is known to you this, and this is acetylene and it is linear. It is known to you this is. So now question is, what will be the correct bond order? This is 109, it is known to you. There is one lone pair and there is two lone pair. Am I right? There is two lone pair. So mode the lone pair, least the angle. So this is highest 180 degree, and second one is CH4, and third one is one lone pair, and fourth one is two lone pair. More the lone pair, less is the bond angle. So this is all about the first one. Now bond angle around 90 degree. Which one has the bond angle around 90 degree? So it is sp3. I have shown you the way how to find out the bond angle, and this is again sp3, and there is one lone pair, but here the two cases we are getting two lone pair in these two. So if you talk about which one has the around 90 degree, means least bond angle, and it is no lone pair, means it is tetrahedral 10. One lone pair means a bit less, more the lone pair bond angle is the less, so it is 107. Now competition or suspect with this one, which one has around 90 degree. So there is two lone pair, there is also two lone pair. So you go to the electronegativity oxygen, electronegativity of sulfur. This is around 90 and this is around 104. So less is the electronegativity, less is the bond angle. Electronegativity less, bond angle less. It is central atom, electricity of negativity of central atom. So electronegativity of central atom decreases, so bond angle will decreases. So naturally we are getting, this is the list. If you cannot imagine which one is the what amount, what will be the bond angle of each and every one, so you try to find out the least bond angle. Least bond angle will be this one, and this is around 90. Nitrogen, phosphorus, arsenic, antimony. So nitrogen, phosphorus and arsenic, antimony in the 15 group, and electronegativity decreases in this way. So this is all our central atom are different. So we are concerning with the electronegativity central atom. So why? What we tell? Electronegativity central atom decreases, bond angle decreases. Very simple thing. So electronegativity decreases, bond angle decreases. So order is this. And here you are asked again in increasing order of bond angle, or which one is the highest, which one is the least. Again you come to know that oxygen, sulfur, selenium, tellurium, there are 16 group. 16 group, oxygen, sulfur, selenium, tellurium. Again electronegativity decreases. Again decrease of electronegativity, bond angle will decrease. So this is the highest electronegativity. Oxygen, sulfur, selenium, tellurium is decreasing, means bond angle will decrease. So this is the order. All are from entrance exam. This sometimes I forgot to write right side. So this is a peculiar one. It was asked in JEE mains. So here you see NO2 plus and O and NO2 negative. So you try to find out, this is 5 and oxygen is 6. 6 to the 12 and 1 electron equal to 1. So you are getting 18. 18 divided by 8 is equal to 2 lone pair. Am I right? So 2 bond pair and 1 lone pair. 1 lone pair. So total is 3. 3 means sp2. So here in this case you are getting sp2 and arrange in increasing order of bond angle. And here you see this is 5 and oxygen is 12. 12 minus 1, it is 11. 11 5 equal to 16. 16 divided 8. No remainder is the 2. So it is sp. So here you are getting sp. Am I right? This is also sp2, but there is odd electron. There is one odd electron and there is minus sign. So repulsion here is moved. This is sp, means it is highest. Bond angle is highest. So now confusion with this one. Both are sp2, 120, 120. But there is odd electron, but here is one lone pair electron. So more the lone pair of electron, less is the bond angle. So this will be odd electron a bit moved, and since there is one pair of electron, this is the least. So here one odd electron and here there is minus sign it, one pair of electron. It has more repulsive power, so its bond angle is less than this one. So it is the least, it is second, it is third. This one is very important, CLP bond angle in PCl5. So what is the hybridization of PCl5? Again it is 5, it is in 15 group, means outermost valence electron is 5 and chlorine bromine 7. So 1 7 plus 5 equal to 35 is equal to 40. So this is equal to 5, means sp3d. At the very beginning I told you its structure is diagonal bipyramidal, and I told you at the very beginning that this question is very asked in the entrance exam, and it is asked in BITEE, and where there are two types of bond. One is 120 and other is 90. So what are the bond in B? You are asked CPL bonds in PCl5 are 120 and 90. You find out hybridization, and with the help of this I have given at the very beginning the information to write. So the question was asked which one of A, B, C, and you were asked which of option has all the molecules are linear molecules. It is asked in JEE. It is very interesting one. I will directly come to this one. N2O, a bit earlier I told you N2O is equal to Sp, and I3 negative. I means fluorine chlorine bromine means 7 3s are 21 and 1 22, and you divide it by 8. So its hybridization is, I have shown it in my earlier class. I3, 1 fluorine chlorine bromine, all are 7 valence electron, 7 electrons in the outermost shell. So 7 equal to 7 3s are 21 and 1 electron here, 22 divided by 8 equal to 2 plus 6 electron left, 6 electron equal to 3 pair. You are getting total lone pair and bond pair equal to 5, means sp3d. But in sp3d there are 3 lone pair, means it is linear. In the second class of the bonding I told you it is linear. So it is also sp, it is also sp. Now come to azide. Azide means N3 negative. 1 nitrogen is equal to 5, it is 15 group, 5 electron, the valence electron 5. So 5 3s are 15, and 15 plus 1 equal to 16. 16 divided by 8 is equal to 2. 2 means there is no lone pair, this is sp. So here we have seen, you need not to check all other things. This set B has all the molecule linear. Joint entrance exam the question was asked, so all the question can be solved out from applying the tricks. Thanks a lot for watching the class, and please don't forget to subscribe the class, and also you are requested to visit my physics in hand classes. I have done it, and please try to see it, and if you find it crucial and important, you can subscribe the physics in hand.